Hi, this is the Science Chef. In this video, you learn about the process of hybridization of atomic orbitals, the types of hybridization, and the shapes of molecules that are formed due to the hybridization of atomic orbitals. So if you'd like to know everything about the hybridization of atomic orbitals, then endeavor to watch this video to the end. From your knowledge of hybrid species in biology, can you guess what hybridization is in chemistry? Alright, let's see whether you guessed right. Hybridization is the mixing or blending of two or more orbitals of different energy levels to form a new set of orbitals with the same energy level called hybrid orbitals. Examples of orbitals that undergo hybridization are the 2s and 2p orbitals, 3s and 3p orbitals, 4s and 4p orbitals, 4s, 4p and 4d orbitals, etc. Our focus in this lesson shall be on the s and p orbitals hybridization using carbon as a case study. So let's now look at the types of the s and p hybridization, starting with the sp3 hybridization. In the sp3 hybridization, one s orbital of one energy level combines with the 3p orbitals of that energy level to form four new hybrid orbitals called the sp3 hybrid orbitals. Note that even though the s and 3p orbitals are from the same energy level, according to Hofbauer principle, the p orbitals are of a higher energy level than the s orbital. If the Hofbauer principle is anything to go by, the energy level of the new set of hybrid orbitals will be in between those of the parent orbitals. So where exactly do you think they will be? Will they be closer to the s orbital or the p orbitals? Let's have your answers in the comment section. Since 3 out of the 4 hybrid orbitals are from the p orbitals, it means that the sp3 orbitals would be closer to the energy level of the p orbitals than that of the s orbital. Example is the hybridization of the 2s and 2p orbitals of carbon to form sp3 orbitals. The shape of an sp hybridized orbital is a blend of the spherical s orbital and the dumb shell p orbital. During bonding, an sp3 hybrid orbital can bond with another s and p hybrid orbital or s orbital to form a sigma bond. When this happens, the bonding pair electrons in all the 4 bonds of the molecule will repel themselves to the 4 corners of a tetrahedron. So what do you think will be the shape and bond angle of that molecule? Yes, you're right. The molecule will have a tetrahedral shape with a bond angle of 109.4 degrees. The second type of s and p hybridization is the sp2 hybridization, in which one s orbital of a given energy level combines with 2 of the 3 p orbitals of that energy level to form 3 new hybridized orbitals known as the sp2 hybrid orbitals, while one of the p orbitals remains unhybridized. The new energy level of the hybridized orbitals is closer to that of the p orbitals than the s orbital. Why is this so? Drop your answers in the comment section. This is obviously because the p orbitals make up about 2/3 of the sp2 orbitals, while the proportion of the s orbital is 1/3 of the hybrid orbitals. Carbon also undergoes sp2 hybridization using its 2s and 2p orbitals. When bonding, the 3 sp2 hybrid orbitals can combine with another s and p hybrid orbitals and 2s orbitals to form sigma bonds, while the unhybridized p orbital will also bond with another unhybridized p orbital to form a pi bond, leading to the formation of a double bond in the molecule as shown on the screen. There are 3 bonding pairs of electrons around the central carbon bearing the double bond, which makes them to repel themselves as far apart as possible towards the 3 corners of an equilateral triangle with a bond angle of 120 degrees. So what do you think will be the shape of such a molecule? Leave your answers in the comments below. The shape of a molecule in which its central atom exhibits an sp2 hybridization is said to be trigonal planar. To learn more about the shapes of molecules, watch our video on the valence shell electron pair repulsion and molecular geometry. Check the link in the description. Also, if you're sure you are getting any value from this tutorial, kindly hit the like button and drop your comments. We would love to hear from you. The last type of s and p hybridization is the sp hybridization, where one s orbital of an energy level combines with only one of the three p orbitals to form two new hybridized orbitals called the sp hybrid orbitals. The other two p orbitals remain unhybridized. You can rightly guess that the energy level of the hybridized orbitals will be halfway in between those of the parent s and p orbitals, since they both made equal contributions to the formation of the new orbitals. Carbon undergoes sp hybridization using its 2s and one of its 2p orbitals. During bonding, the two sp hybrid orbitals can bond with another s and p hybrid orbital and an s orbital to form sigma bonds, while the two unhybridized p orbitals will also bond with two other unhybridized p orbitals to form two pi bonds, leading to the formation of triple bonds in the molecule as shown on the screen. The two bonding pairs of electrons around the central carbon bearing the triple bond repel each other as far apart as possible along a straight line, giving the molecule a linear shape with a bond angle of 180 degrees. In summary, sp3 hybridization occurs between one s orbital and three p orbitals and leads to the formation of only single covalent bonds called sigma bonds. The molecule that exhibits an sp3 hybridization has a tetrahedral shape around the central atom with a bond angle of approximately 109 degrees. Examples of such compounds are the alkanes. sp2 hybridization occurs between one s orbital and two p orbitals, which leads to the formation of a double bond that consists of one sigma bond and one pi bond. The sp2 hybridized molecule has a trigonal planar shape with a bond angle of 120 degrees. Alkanes are examples of compounds that exhibit sp2 hybridization, while sp hybridization occurs from the mixing of one s orbital and one p orbital and results in the formation of triple bonds made up of one sigma bond and two pi bonds. The molecule that exhibits an sp hybridization is linear in shape and has a bond angle of 180 degrees. Examples are the alkynes. So if this video was helpful to you in any way, kindly drop a comment and give us a like. Also, if this is your first time here, subscribe to our channel and turn on your notification bell to always stay updated with our new uploads. A wise man once said, hard work beats talent when talent refuses to work hard. So keep working smartly till I see you when I'll see you.